In the future, things will be better. We hope.
Yeah, they will.
Hello and welcome to Fall Through, your source for deep conversations about technology, software, and computing. I'm your host, Chris Brando, also known as Scriptable, and today it's just Matt and me again, and we are actually going to talk about worse is better, the New Jersey versus MIT ideologies of how to build software and how that relates to a lot of things in the world. Not only things like Go, our beloved programming language that we love writing so much, but also, more broad things like electric vehicles in the United States, and I'm sure a few other things that I can't think of at the moment. As per usual, we will have bonus content for our supporters. If you're not a supporter already, head on over to fallthrough.fm/subscribe and sign up today. If you're not following us on social media, please give us a follow there. And if you're watching this on YouTube, please hit that like button and that subscribe button while you're at it. And with that, let's get into the show. Hello, viewer/listener. How are you doing today? It's just a panel of me and Matt. Nice little duo. I feel like for a while it was like duo of Matt and Angelica, and now it's a duo of Matt and Chris. So it's a good old time here. But yeah, Matt, how are you doing today?
Great. A couple days before Christmas, and I am super excited for Christmas. So it's a good time.
Yeah, it's gonna be the end of the year is always so quiet. So
Yeah.
it's a fun time to get to wind down and all of that.
Also, like, I know our listeners are like, where are your guests? That we have them scheduled. Some, had last minute cancellations and stuff, but we have guests coming. It's just this end of the year time is very, very hit or miss with that. The schedules are all over the place. So
I feel like January is a good time to get people on because everybody's fresh in the new year. There's no holidays or traveling or any of that. So
yeah. We're gonna get the people that made a New Year's resolution to be on podcasts, and we're gonna be like, you said this. Let's go.
You said this. Come on. Join the podcast. Yes. But yeah, so today we're going to talk about this idea of worse is better. And we're going to explain like what that means, what the New Jersey versus MIT ideological differences mean, and then get a bit into the way that like we see this playing out in the world and how we, kind of specifically see it as playing out in Go at the moment, and how we kind of hope in the future we can steer ourselves toward maybe fixing some of the issues that have come up because of these differences in ideology. And then, as per usual, wherever Matt and I go, we shall go. So yeah, I think it'd be good to start with just an explanation of what worse is better means and what these ideological differences actually, like, at the end of the day, boil down to. So worse is better is a kind of joke essay that Richard Gabriel wrote in 1989. I believe he was at Bell Labs, but I'm not 100% sure. I'm pretty sure he came from the Bell Labs side of things. But it was this essay about the differences between how Bell Labs approached building software and how MIT approached building software. So the MIT approach, which is often called the right thing approach, focused on interface simplicity mattering the most, having correctness be the most important thing, right? One of the most important things, where correctness is always paramount. You can never have something incorrect in the system. Consistency also being paramount, as in you shouldn't have any inconsistency in the problem. And you have to cover all of the cases for something, right? So you're talking about it's a simple interface plus correctness, consistency, and total coverage of your problem space. This is in contrast to the Bell Labs approach, which focused on having implementation simplicity. So instead of the interface necessarily being simple, the implementation should be simple. And it's better to have things be simple instead of being correct. And consistency can be sacrificed for that simplicity. And completeness can also be sacrificed for simplicity, right? So I guess in a short way of saying it, the MIT approach is about being correct and having correctness, whereas the New Jersey approach is being simple and having simplicity. Most importantly, we're talking about simple, not necessarily simplistic, right? So you still need a solution that actually implements it. If you want to understand the difference between those things, Rich Hickey has a really good talk called Simple Made Easy that you should definitely go watch. A good example from the essay is about what happens when an interrupt occurs during a system call. And this kind of shows the distinction between the two different ideologies here. For the MIT approach, the kernel has to perfectly save all of the state and restore all of the state so that the user never knows an interrupt happened. And this actually wound up requiring over 100 pages of assembly code to handle all of the different edge cases. Whereas the New Jersey approach to this problem was just to return an error code to the user and have them retry, right? The implementation is easy, but the interface is uglier. And that actually allowed the system to be shipped to users, right? So this is it's not technically correct to return an error to the user because an interrupt happened during system call, but this is like the pragmatic thing to do. And I think as many of us know, like the New Jersey approach won out, I think, kind of in the industry, because the New Jersey approach is what gave us things like Unix and C, and the MIT approach is what gave us things like Lisp. Now, Lisp is great, and I don't think that we should say that, the MIT approach is never correct. But I would say that as far as the tech industry influence goes, Unix and C have had a much larger impact on things than Lisp. So again, Lisp has had a very large impact on the industry, so we're not trying to trivialize Lisp there. But I think what's important for this conversation as well is that 2 of the 3 founders of Go, Rob Pike and Ken Thompson, were from the New Jersey School of Thought and baked those ideas and that ideology into Go itself, right? This is why, Go had no generics for a very long time, why it doesn't have exceptions or inheritance, why it has a small feature set. Rob Pike gave a talk about this called Less is Exponentially More, where he focused on this ideology of like, we should do fewer things. We should have consensus before we add a feature to the language. And I think a lot of those things are what brought a lot of people to Go in the early days. So Matt, what do you think about these ideological differences?
Obviously, as somebody from New Jersey is always better. So, there's, I mean, we could just end the podcast right there. But no, I mean, this is great because it's weird because you kind of see it, like being someone that kind of lives in this area, you kind of do see that sort of like pragmatic mindset of good enough versus perfect. We don't really stress about making something ultra correct. We make sure that it solves the problem at hand and, nothing more if necessary. And I like that sort of approach to things because it leaves you room to focus on what matters and then expand it in the future. And when you look at something like Go through this lens, you're like, oh yeah, it solved the problem it set out to do. And really the Go's problem or the problem that Go was trying to solve at the time was kind of twofold in my opinion. It was take better advantage of multi-core systems, right? So give some concurrency primitive so that you can take better advantage of Core 2 Duo chips and beyond, right? And then the other thing was make the language simpler so that more people can program without having to go through some software engineering degree thing, right? Make it more approachable to the layperson. And some people don't like that because it goes too quote unquote simple, but like it did bring in a whole new generation of programmers, which I think is a good thing. Is it the most correct, perfect language ever? No, but I think it solved those problems, and that's the reason why you see such like a big boost of cloud native technologies being built on Go, because at the time it just enabled that to happen. It was just in the right place at the right time. So I like that. If it were like an MIT based approach, we'd still be writing the spec for this thing. You know what I mean? Like we'd still be we'd have nothing done. And I'm not knocking that approach. I'm just saying sometimes you have to favor being more fluid and getting the problem solved rather than being very ultra correct and not doing anything.
Yeah. I think this is one of the cases where the phrase "it's not rocket science" applies really well because if you are, designing a rocket, well, there is a lot of room for pragmatism. Correctness is paramount, right? If you don't get the design of your rocket correct, there's going to be a lot of fallout from it. Sometimes literally in the form of exploded rockets in the sky raining stuff down on people. But also just from the high cost of things. Like the need to get things like rockets correct is very high. So an approach of kind of trying to do all the correctness and trying to make it so you cover all the edge cases is worth it for something like that. But I think for a lot of things, especially things like programming languages, that approach will just put you in like analysis paralysis and design paralysis, where you do spend a lot of time trying to figure out how to do it, right? Like, say that, they did decide that Go needed to have generics. Well, it took Go a long time to come to a generics approach that itself isn't even complete or necessarily correct, right? We still can't have generic methods. We can only have generic functions. So like having to have the approach of like it needs to be correct, it would not necessarily yield the language that we have, as you pointed out. But I think that like those early underpinnings, I think, are what shepherded the language forward, and I think leaving those underpinnings is what has left us where we are with Go, I would say. I think it's the fortunately listener / viewer, sorry, we're gonna have to touch on modules a little bit, because I think it is a good example of where we have departed from the New Jersey way of thinking about things, and I think it does exemplify this distinction in thinking, or really at the end of the day, a lack of doing either, right? I think modules was originally approached with the idea of we need more correctness to drive adoption by enterprises. Like, enterprises want a dependency management solution. We need to drive that with correctness. And there was kind of, I think, a foundational underpinning of, two things that share the same import path must be compatible with each other, right? That was like the underpinning of all of this. And I think that's a decent underpinning. But I think there were some fundamental flaws in both that ideology, but also the ideology of other solutions out there. And that flaw was in believing that SemVer is the thing that people would be able to follow. And in the real world, people don't follow SemVer, right? We like to think we do, but we really don't. And if you build anything, whether it's dep or vgo or glide or npm or cargo or any of these things, with the underpinning that SemVer is correct, you're going to wind up with broken solutions. And I think the key difference between things like dep and npm and cargo is that they lean much more into the reality that people don't follow SemVer, whereas modules assumes it as fact, and things will break if that fact is not upheld. So I think that pushes it more toward the MIT way of thinking about things and that ideology, and away from the New Jersey way of thinking about things. But I think I don't think it landed in the actual MIT way of thinking about things, right? If that makes sense. Maybe that doesn't make sense. But like, what I'm trying to say here is that like we made with Go, the leadership tried to push it toward more of the MIT way of doing things, even though its underpinnings and its community were largely in the New Jersey way of thinking about things. And that has left us stranded in a desert or a void in between the two, where we're kind of missing both at the end of the day, right? Because modules fundamentally is not correct. Like the one example I'll bring up is that the underpinning of it, again, is that two packages with the same import path must be compatible with each other. But you can trivially violate this by having v2 of a module, where v2 is in the module name, and a directory called v2. And that could be, with the v1 of the module, which doesn't have to have the v1 suffix. And so you can have two import paths that are like example.com/v2/foo that actually point at two completely different packages that might not be compatible and might never have been compatible with each other. I'm like, this was a design decision, right? You could have just forced for semantic import versioning, having to put v0 and v1 in the import path. And anything that doesn't have those doesn't use semantic import versioning, making it optional. Or you could have disallowed having any directory that is prefixed with a v and then a number or a series of numbers, and that also would have fixed that problem. Both of those would have been pragmatic, but obviously neither of those would have been correct. So we wound up in this kind of limbo state where there wasn't a correct nor pragmatic solution, and we're just all kind of living with that to this day, right? You just have to make sure you don't step on that particularly sharp edge of modules, right? The ironic thing is that if you wanted to slowly move your packages over from v1 to v2, and you started it by having a V1 and making a V2 folder and putting things in there and then cut a V2 version, you'd easily step on this. So it's like, even in the upgrade path, and the same is true from like V2 to V3, although it's less so for those because you'd have the module name in there after V2 and above. But this is still like a sharp edge you could run into during like a kind of crucial part of you upgrading from your initial version of the module to the next version of the module, right? From V1 to V2. And like, that's just one example. There's tons of these little things sprinkled throughout, these assumptions about correctness that ultimately don't meet reality, which I think is where the issue across the board is, and what the issue that ultimately we all need to fix if we want to make, you know, our programming languages and our other endeavors successful.
I think it's important to note too that, like, again, I'm going to reiterate this because I know our listeners, you're probably like, I don't want them to talk about modules again. And we don't either. We really don't either. But there's a interesting, like, it's a good case study for this sort of, these two like ways of thinking and working, right? This sort of Bell Labs, New Jersey, and this sort of MIT, Massachusetts sort of way of thinking. And it's not so much as like, this way is better than the other way or vice versa. It's more of, when you've started a project, especially like a programming language, under the guise of one sort of idiom or mindset, and then you shift somewhere along the way, and if you don't make that shift like very apparent and very explicit, like Kris already said, you do leave us in a position of like disarray, where now no way of thinking is the way of thinking, right? There is none, because we don't know what we're doing anymore. And like, it's that sort of inflection point, that point of change, where things get very weird and get very uncertain. Because like Kris was saying, if you have a community that's in your programming language or whatever, right? It could be rocketry, it could be any example. And Kris and I will touch on other examples that are not even programming related at all. But if you're in a community for something that's following one sort of way of thinking, and they change that way of thinking along the way, you now feel alienated, and you feel like, wait, this is not the thing I joined to start. And what I wanted to note here in the Go specific thing is, I pulled up the Stack Overflow developer surveys, and I look at the data, and you see, like, you know, Go increased some places as like a used programming language, and then it dropped a couple places, and then it's like it increased in terms of aspired to use the language, and then it decreased. And there's some patterns in there for sure, but it's data. But for me, like, I look on social media and I see people not happy with Go, and there are many people that are happy with Go, right? You get paid to write it and blah blah blah, and that's fine. But when I see a growing number of users, especially people that I respect, that are like, yeah, I'm not using Go anymore, I need to dig in to understand why, right? Not because I'm going to go try to save Go. I don't care. I don't write Go, like the language. I don't maintain the language. But it's always good to understand, like, why is the general culture around this thing that I love and that I use, why is it changing? So I can understand it for myself and reevaluate my decision to use this thing. And that's important. And that's kind of where I was like, hold up, you developer who I like look up to, you're not using Go anymore. Why? Oh, because you have a different, like, you're operating in a different sort of paradigm now that Go is not the right fit. Okay, cool. Oh, but you other developer, you're not using Go anymore. Why? Oh, because the language hasn't evolved in these areas. Oh, okay. And you start to piece together, like, things are changing, right? And the sentiment around the language is changing, and it's good to kind of reevaluate that periodically. Like I said this in previous episodes, where you should every now and then come up for some air and reevaluate the things you do. And this is a moment where I'm like, if I weren't tied to using Go, I don't align with where it's at any longer, right? There are things that I've changed and Go's changed, and I'm like, there's things that I can do differently. And not to pick on Go, and I'll end my little monologue here, I feel the same about other things too, right? As Kris and I will talk about electric cars. We'll talk about GitHub as well. GitHub is in a very, very bad position right now. The sentiment around GitHub is very negative right now, and for good reason. And I feel the same there. There's an ideology shift, right? There's a mindset shift behind how GitHub started and where it is today. And that has something to do with that sort of Microsoft acquisition thing too. But like that inflection point, that sort of change of ideologies is so crucial. And this is where things can either thrive or die. And we're seeing it happen in these areas.
Yeah. And I do want to say, you can still see like the New Jersey approach coming through on things within the Go sphere, right? Like generics is a perfect example of this, where like generics is certainly not a holistic solution, right? We don't have things like generic methods. There's still like the interface is still like a little bit rough. It's not the simplest of interface, but you know, it gave us a piece of what everybody wanted. It gave us a little bit of a step forward. And that's a very New Jersey approach to it. And I think as well, the way that we have approached error handling, where we're basically saying, this is not something we're going to solve, is also a very pragmatic approach to it, right? It's a very much like, okay, maybe there isn't a correct solution here. So I do think we as a community, and I think the Go team as a whole has learned from the past here, but I think it's not enough to just learn from it. I think we have to really, really realign on the New Jersey ideology. And I think, you know, fixing the dependency management problem or fixing dependency management in the language is one of the things that does need to still get done, because, you know, people are tripping over these edges every day. And, you know, a fundamentally broken system is not one that should be left in the language long term. But I also think that the premise here of why we did all of this in the first place is also kind of a deviation from the New Jersey methodology, where like GoGet was seen as like the official dependency management tool, even though it was just like a tool that shipped with the language, and that you should go use something that is more appropriate for you to use. And to be fair, like large enterprises do. Like if you know, Google uses Blaze, and Facebook with it, I think it's Buck. I think it's called Buck. And Twitter had Pants, and like there's all these build systems that if you know want to compile Go in these things, you don't use Go build or the Go toolchain. You kind of use the compiler directly. Have these rules that get built and put in that compile the code for you. And it's like a completely different way of compiling and building Go, made for the environment that it's in. And like that has always felt like the solution here, the pragmatic, the New Jersey approach to it of like, okay, let's not give something official here. Let's give something that will get people started, and then be like, hey, you got to go build the thing that you need yourself. So I think that's like an important point. I think I brought that point up before, but I think it's important to reiterate that like this is not a all hope is lost conversation, or that there's no path back conversation. I think this is a, hey, here's an interesting thing that we have discovered about why so many of us are feeling the way that we're feeling, right? I think that over the course of this year, we have tried to figure out why is it that we feel the way we're feeling. I think back in our Is Go Dead episode, I don't remember what we called it, but that's like, I think what people remember the episode as. I think many of us on the panel were like, there's something here that has changed, or something that's different. It feels different than it did in the early days. What is that thing? And I genuinely think that this might be the thing. I think this might be the root cause of it, is this shift in ideology. And I think it's important to like, A, recognize that, and then B, talk about it so that we can perhaps shift back to it, or maybe discover that this is not the issue that it seems to be. But I feel pretty strongly that this is probably the reason why so many people are feeling the way they're feeling about Go. I also, you know, can't like, I mourn the opportunity loss from what we could be doing with Go, from focusing so heavily on some of these things like dependency management, which is like, at the end of the day, like Go could have been like, we could have basically done the things that say Zig is doing, or some of the things that Rust is doing, but in a more like Go like pragmatic way. I think that would have been really cool. Like part of me wishes that Go could be the language that Mitchell wrote Ghosty in, right? I definitely do not think, I mean, I think when he said, maybe the first episode he was on, he was like, yeah, and like I was definitely not going to write Ghosty in Go. That kind of sat with me, because I'm like, it feels like Ghosty should be something you can write in Go. It feels like that should be in the wheelhouse of the types of applications that you can write in Go. And I think too, like someone that is like one of the most prolific Gophers out there, to kind of feel like, yeah, this language is not going to do what I need here, should tell us something, should tell us that maybe we are like a little bit on the wrong path here and we should do some course correction.
That should tell us something in itself, right? Like you're saying, this is not, again, I want to be very clear to the listeners here. This is not us saying like Go sucks or whatever. This is just when you see prominent people that were champions of a thing leaving that thing for something else, or not just leaving, but just not choosing that thing again, it does prompt, or it should at least prompt, a discussion of like why. What was missing that Mitchell didn't write Ghosty and Go? Why? What was missing there? What was missing that Bill Kennedy was tripped up over how to version modules correctly or whatever the other day he asked in the Go for Slack? Like, what about this is causing these industry sort of titans around Go to say, you know what, this is a pain point. I'm fumbling here, or I'm not even going to choose this language. Like, what's causing that? And if we can't have that discussion, if it's just going to be met with like, oh, you're holding it wrong, or oh, that's just what Go is, then the language is just going to die, right? Like, it's just going to die, and it's going to like, nobody's going to care about it in 10 years when they all switch to Rust or Zig or whatever else, right? TypeScript maybe. And like, that's the thing is opening up the table for these discussions to see like what's changed and why did it change and can we do something about it? And Kris, to your point about like the whole Bell Labs, MIT sort of difference, NJ versus MA sort of difference, I tend to think that it's a good framing for it because you're right. Like back in the day when Go was released, it was very, tactile or tactical, and it solved the problems that it needs to solve. And it was very clear about that. Hey, we're making multi-core systems easier to use for programmers, and we're making the programming language easier to use for programmers. That's like our guiding light. And then at some point along the way, the guiding light was sort of lost, right?
Yeah.
And this sort of correctness thing creeped in, and this sort of 1.0 compatibility thing creeped in. It was very rigid to the point now where you had people coming to this language because it was more fluid in that regard. It was, I could use it for this or that. Now you're saying, here's my box, say in there, and that doesn't sit well with people. And it's just like, what did you expect to happen? Right? What did you really expect to happen when you do that to people, especially people that enjoyed that sort of like fluidity and of the language?
Yeah. I do think it is it's not just about Go either, right? I think it's about our industry as a whole, because Go represented some amount of diversity, some amount of uniqueness in the language landscape. And one of the things that has been lost here is that I don't know if there's another major programming language that fills that gap that Go used to fill, right? This like ultra pragmatic language that's focused on, at the end of the day, focused on enabling large teams of software engineers to build good software, right? That was
Right.
the one of the underpinning reasons of why Rob Pike and Ken Thompson and Robert Grusmer wanted to create Go. They were, dealing with these really long builds in C++ and all this other stuff happening. They're like, we have to find a better way to do this. We have to find a way to make it so that, large companies, large enterprises, they can build the software they need without needing to have like the most expert people on staff to, figure out how to manage large distributed builds of their software so it doesn't take hours to compile something, right? A way for the average person to just pick up a language and use it for what they need and, bend it to what they need it to be. And I think that loss in the software industry as a whole is something that can still be corrected, and we should correct it. But I think if we don't correct it, that has larger implications for like the rest of the industry. It's kind of like if Rust started doing something that made people start moving away from it or not wanting to use it as much, I think that would be a not great thing, because Rust is unique in the way it does its memory management. And I think it's important to have language like that and to have that type of ideology that exists in the software engineering world. So I think it's not just that like programming languages, they don't just exist in a vacuum, right? And
Right.
the more that we push programming languages to each other, the more diversity we lose, and the more the worse I think software gets overall, right? I think this got brought up in the Is Go Dead pod episode we did as well, where it's just like, what makes Go different from say TypeScript or from Python or from these other languages? And there used to be like a definitive set of things where like, this is what makes Go distinct from it. And if that starts fading, as it has faded with some other things, then like we just have less choice, less realistic choice. Maybe there's all these different languages, but if they're all so similar to each other, is there really choice there?
Right. Is there choice? And like, what is the purpose of them? Right. Not even just is there a choice to use other things, but why are we spending bandwidth maintaining all of these different languages when they're really all similar? Yeah. Right. Like why not just refocus some of that effort on problems that actually matter? Right. Do we need a 107th language? No. You know what I mean? Unless it's going to solve some specific problem. Right. If you're going to sit here and tell me like, hey, Matt, I made this language to solve this very specific problem because the others were too generic for it. That's a good thing. That's that sort of New Jersey thinking again, where it's like very focused on a tactical problem and solving for it, rather than being this ultra perfect, correct thing. And yeah, I mean, that's kind of the gist of it. Is you have these two mindsets. One is focused on getting things done. One is focused on like very correctness to the point where you can like kind of prove it, and both have their areas to be sort of implemented, right? Both have their pros and cons, but that inflection point when you see it change, that is kind of a telltale sign of like, oh wait, something's wrong here. We should probably talk about this more.
Right. And I think perhaps it's underappreciated, some of the things, or the scope and scale of what some of the things Go did in the early days. I think is underappreciated. Like GoFumped, right? Before GoFumped, there were formatting tools, right? Like these things existed, but GoFumped represented a big shift, right? In that like it did have like a singular format that like everybody was going to use, and I think it also pushed this idea that we should be able, like it should be easy to parse, interpret, and dump your syntax, right? Like that's the big thing that GoFumped gave us, right? GoFumped, in order to build GoFumped, you needed to have in the standard library basically a way to parse Go and then process its ASTs and then dump it back into a file, which, you know, some compilers had some things, but it wasn't something that was like in a lot of standard libraries or things like that. But now I think like most programming languages have a way to do this, because you need to have a way to do this in order to build the tool that does this thing, right? There's a plethora of parsing libraries that you can use now to form an AST and dump that back to disk. And that leads to us being able to do like more and more advanced things. It kind of leads us to this whole like LSP ideology that we have now, where it's like, oh yeah, like processing and doing static analysis is just what we all do. And I think it would be fair to trace that back to GoFumped, among many other things. But I think GoFumped was like a very prominent thing in that path. And had it not been for GoFumped, we might not have as robust tools as we do now for doing static analysis and that kind of thing. So it's those types of shifts can have like reverberations throughout the whole industry that I think are super important, and that we shouldn't sleep on, or we shouldn't underestimate, you know, how useful those things are at the end of the day.
No, I agree.
There's another point I was going to bring up, and it just like flew out of my brain as I was saying all of that.
No, you're good.
I'm sure it'll come back to me. Oh wait, nope, it came back. I think one of the ways that this kind of consolidation of ideas manifest is, sorry, listener, once again, independency management. But this isn't about modules. This is about all the other dependency management tools, and the thing we brought up earlier about the assumption that semantic versioning is A, correct, or B, the correct way of doing things, and C, that people are actually going to follow it. And I kind of want to say like a couple things on this. I think it's important to point out like, why is semantic versioning kind of not correct? I think first, I think there's a fundamental flaw in its foundation, where it assumes that people will create a well-documented public API, which I think we all understand is like not something people do. People will write like, you know, the things they have to write, the function interface with the function signatures, your types, all of that. You have to write that. But rarely are people specifying the behavior, which is part of your public interface. But I also think that the idea of bug fixes being something that can fit into a patch, which is meant to be a backward and forward compatible situation, is fundamentally flawed, because if you have something that you call a bug, Hiram's law, or Hiram's, was it rule or law, whatever it is, tells us that someone probably depends on that bug for that functionality, right? People will depend on undefined or underspecified behavior in your APIs, which means that a practical tool or a practical versioning system would understand that and would say, okay, yeah, you can't just fix a bug and say that it's backward compatible, because it's likely that it's not. Like, you've changed some functionality, something has changed, and someone that was depending on that is now broken. And we all kind of just like cover our eyes and say, well, that's their own fault. But like, that's not a practical or pragmatic approach to the world, right? But it's also not a correct approach to the world either, because we're going to shoot for correctness. You're going to sit down and everybody has to define what their public API is in some very specific way. And then it's like, okay, well, if you're outside of this, then we can break you when we want to break you. But I think it also makes semantic versioning a little bit of a wonky thing, because it's like, okay, well, some breaking changes are allowed in the place where we say breaking changes aren't allowed, right? Like both bug fixes and security fixes fit this, where it's like, oh, you can do a patch release and put a security fix in there. But I also think the idea of like you being able to stamp a version on something and then being able to make a compatibility assumption with other things, irrespective of the caller, is also a fundamental flaw in the design of semantic versioning. Because with semantic versioning, right, with any kind of versioning thing or with any kind of compatibility situation, you have three actors that you care about, right? You have the, we can call it an application, or you can call it like a processor in the terms of a file format. You have the old version of that file format or library, and the new thing, the new version of that file format or library. And what you really are trying to say, like if you take file formats as an example, let's take HTML, right? HTML is forward and backward compatible. What does that mean? Well, it means that a parser written for HTML4 can parse HTML5 successfully, right? That means it is forward compatible, right? Something written for something old can read something new. And backward compatible means a parser written for HTML5 can read HTML4, right? So something that's written for the new thing can read the old thing. The problem with semantic versioning is it pivots what the subject of that sentence is, basically. So in the case we were just talking about, we're talking about the parser's perspective, right? The parser was written for HTML4, it can read HTML5. The parser was written for HTML5, it can read HTML4. That's where you get forward and backward compatibility from. When we talk about semantic versioning, we're not talking about the application, which is the caller, right? In that case, it'd be like if you wanted to put these terms in the same plane as the file format compatibility, just like terms, you would say, oh, an application written against V1 of a library or dependency, if it can use V2, then that would be forward compatible. If a library, or if an application written against V2 can use V1, that would be backward compatible. But that's not what we actually claim, right? When we say backward compatible, we're talking about the first scenario. We're saying something written for the old version of a library can use the new version of a library. But when we talk about file formats, that's called forward compatible. When we're talking about SemVer, that's called backward compatible. We've flipped. And the reason we do that flip is because we go from talking about the application or the parser to talking about the library itself. From the library's perspective, if an application written for the old thing can use this new thing, then that is backward compatible, right? This library is backward compatible with the first version or the old version of it. Now, the reason that this is incorrect is because the library does not know what of its many interfaces, like many of its like interfaces, its types, its functions, its methods, it doesn't know which of these is being used by an application. So you can't definitively say that something is a backward incompatible change unless you change every single thing in the API surface, in the public API. Right? That's the only time that you could claim that something is backward compatible. Because if you have one function that is the same across your quote unquote, like from a V2 to a V3, and you have an application that uses just that function, then you wind up in a situation where for that application, there is no breaking change, right? So semantic versioning in that way is a lie because we have not correctly identified which party is responsible for the compatibility, which is the application's perspective, and application is responsible for the compatibility. I know that was very long, but the basics of it is that semantic versioning at a foundational level does not tell us what we think it's telling us. It does not tell you if there is a compatibility there. It cannot tell you if there's incompatibility. You can only know about compatibility once you take the perspective of the application. And every single dependency management tool for every major programming language depends on semantic versioning, right? They depend on this assumption that we can tell compatibility not from what your application is actually doing and what the other, software that might depend on things is doing, but from the libraries in and of themselves. And this consensus and this consolidation is what leads to our security problems, right? It's what leads to our lack of ability to have a coherent supply chain. It's what leads to all of these things at the end of the day. And so that is the real consequence when we consolidate on one way of thinking about things or one way of doing things or chasing some idealistic correctness, right? You wind up sucking all of the diversity out of the room and all of the air out of the room except for that one solution. And if that solution is founded in a correct ideology, then it's maybe fine. But if it has foundational problems to it, you're just screwed. And I think that's the place where we are as an industry at the moment.
Steve gonna be mad at you when he hears all this. No, just kidding. Well, it's funny that you brought up the semantic versioning stuff. Well, not funny, but it's good that you brought it up because this is something I've been struggling with at Oxide. For example, the sort of ultra correct way of thinking is that, yes, every breaking change is going to result in a major version and every feature is a minor and every patch is a patch or whatever. And that sounds great. I guess this is my problem with this sort of Bell Labs at my MIT thinking. All of this stuff from the MIT sort of way of thinking sounds really good on paper. It's like a freaking nerd's dream to sit there and be yeah, the system is just perfect. It's perfect. It's yeah, it's so perfect that nobody can use it. Nobody can practically use it. It's I built the most perfect house. It'll never get ruined. So you built a house with no doors and no windows because nobody's ever going to go inside. Is what you're telling me. But the act of using something is quote unquote ruining it because you're using it. You are, it's going to require maintenance if you use something. And for me, the SemVer thing is particularly topical because in the cloud world, you generally you're generally using latest to latest, really, right? You have these cloud providers like AWS, Azure, GCP. You don't hit a version of their API. You hit their API in general.
Right.
They always have latest deployed, right? Really, that's what it is. It's just always latest. And their SDKs are always tracking latest. So really, if you want to stay current with their API and make sure that whatever you're using is compatible, you just use the latest version of the SDK at the time. And now for features that don't change often, maybe instance create API or whatever, that really doesn't change too often. It's very stable API. You could probably use a very old version of SDK and it'll just work, right? Because nothing there has changed in many, many releases. But if you want to use a new API, you're going to need the new version of the SDK. Case in point, of course. Then I look at Oxide because obviously, that's where I am. I'm responsible for our Go SDK, and that means I have to make sure it's compatible with our API. But we are not a SaaS provider, meaning there is no latest Oxide API, right? There is no we can't just assume that everyone's hitting the latest version of the Oxide API because customers may have their Oxide deployments on vastly different versions from one another. One can be running the latest version, one could be running 2 versions behind. Now, what does that mean for me as an SDK maintainer? What do I do? Right? I have to make sure that either the latest version of SDK is always compatible with the last N releases, which is a nightmare because that means now I have to have different functionality in SDK to say oh yeah, we're going to call this instance create method when it's the latest and this instance create when it's the N-1 version and so on and so forth. And that's just a nightmare, right? Or the other thing is we can stay behind the latest version of the API because now our API has like versioning in it, like similar to how Stripe works, right? We don't do like path versions. We do like a header that says, hey, this is the version we expect. And then the API on the back end will do like translation and whatnot to go to older versions and back of schemas. So the other approach here is, my SDK will stay older. And then when it gets to a point where like we're confident that all the racks out there are updated to at least this version, then we can bump the SDK, which sucks because now like I have to forcefully stagnate myself, right?
Right.
So I was thinking about this in the sort of topic of SemVer, where I was like, SemVer doesn't help me for anything here. It does not let me tell my users anything about the system. What is version 1.2.3 of the Go SDK for Oxide? What does that mean? It means nothing, right? What is version 2.1.3? What is version 3.7.2? Like, what are these versions? They don't mean nothing, because what you really care about is what version of your SDK you're running and whether or not it's compatible with the version of the server that Oxide, the API version of Oxide. So it's like that version of the Oxide API has a number, usually from like the Open API spec or whatever. But my SDK version suddenly can't use that number because it's not a SemVer compatible thing. Like I'd have to make some large, 0.big version .1. It's incompatible. Why can't I do that? And then to further this point and then kind of, stick it at Go a little bit, Go doesn't support anything else in their module system except the SemVer stuff, right? At least not officially on the Go site. When you publish it, it won't show you odd versions. It'll only expect like, XYZ. So it's like now I can even work around this by saying, hey, I'm going to push up a custom versioned SDK, because although it would be available in source control, it won't be there on the Go like website, the Go module, whatever package website. It won't be available there. So it's like, you just feel stuck. The point I'm trying to say with this story is you feel stuck because there's no right solution. There's no right, correct path. You just have to be, tactical and see like, what do my users want and what can I do to at least best help them and guide them towards a future. And like, it's rough when you know that that's the correct way forward, but the tools that you're forced to use for it don't even allow for that thinking.
Yeah. And I think too, the point you brought up about like the allure of, this beautiful world where SemVer works and everything is so clean, it traps us in this like kind of utopic thinking, right? With this utopia of like, oh, but think of how beautiful it is, and allows you to nerd out about stuff, right? Like when modules being developed, like one of the things of why Rust decided to do Vigo instead of dep focused on like a SAT solver, which is NP complete, versus NVS, which is, NL. And like, oh, well, we can do dependency resolution so much faster. We can get correct versions. We can be stable. Like, there was a lot of nerding out about like, oh, look at all of the things we can do. It's like a nice little neat problem that you could solve. You could talk about in computer science theoretical terms and all of that. But like, all of that doesn't matter if like your underpinning is false, right? If it's nice to develop a utopia, but if that utopia doesn't hit reality, then you're not building something that's actually going to solve people's problems. And this is where I think Go had that unique ability to once again completely shift the way that people thought about things, right? And it goes back to GoFumped, right? Because of GoFumped and because the standard library contains all of this wonderful logic around parsing and analyzing code and all of this stuff, we've built a tool in the modern day called Go Vuln Check, right? And that tool will go through and it will statically analyze your application or your library to see if a security vulnerability in a dependency or a transitive dependency actually affects you, right? And it has to be a very conservative approach, right? It only tells you you are not exposed to this, or you may be exposed to this. Or no, maybe it's the other way around. Maybe it says you are exposed to this, or you are probably not exposed to it, right? It can't give like a definitive answer because there's, you can do reflect for calling things and all this other stuff that is much harder to trace through static analysis. But it actually like literally crawls through the tree, crawls through the whole application to be like, okay, here's where the vulnerability is. Are you passing through that call path? If you're not, then you're good. If you are, then you need to actually like do an update here, right? So, and ironically, we've actually built a tool that would do versioning really well for us if you just shifted that perspective from doing security analysis to doing dependency analysis for your dependencies, right? Of tracing through and saying, which of the things are you actually calling? Because then you kind of, in some ways, eliminate the diamond dependency problem. And because either like the things you're calling are like in a compatible version or they're not. Like, you know, when it comes down to a function signature in the simplistic way, right? If you call one version of the function signature and the dependency calls a different version of that, you have the diamond dependency problem. And the way that we've kind of solved this with modules is we say, okay, well, different modules, like different versions of the module have different names, so you can bring them into the package. Like both things can be included in the compiled output, right? But you can solve that, and like you can still have that same sort of solving thing by allowing you to bring in multiple versions of the same package if they're like, say, in incompatible versions, right? And then you say, oh, okay, well, if they're incompatible versions, then you want to pass something between. You got to figure that yourself, but you can still allow that sort of thing if you wanted to, right? There's nothing that says you can't import different versions of the same package multiple times. There's nothing that says you cannot do that, right? So we did this sort of go vuln check way of doing dependency, understanding dependency compatibility, that would actually allow us to kind of let go of SemVer, because now you're talking about dependencies from the perspective of the application or the library, from the perspective of the code. And the question you're asking is there a version of this library or this package that both me and whatever other dependencies need where we can get the same version, right? That's a yes or no question. And if there's not, okay, well then I need to pull in both. And that might break code in some cases, right? Like if you bring in if you bring in two different versions or two incompatible versions of the same package, then you can't pass types between the two because those are technically two different types. But that's something you have to solve anyway, right? You can't pass a type from a V1 to a V2. Like we already know that. You have to have compatibility things in order to do that, right? So that's like, basically what I'm saying is that like there was a path here where we could have built on top of what GoFumped gave us, built on top of what the analysis framework Go has, built on top of what GoVuln has given us. We could have built that as our versioning system. And it looked weird. It would have been very novel. I think people would have been like, what is this? But if you sat down and explained it to people and said, this is a way of resolving dependency hell that doesn't rely on SemVer, which has these fundamental flaws in it, right? And if one language started doing it, if Go did that, I think a lot of other people would have looked at it and been like, huh, I wonder if we can start doing that. And it would not have been an MIT approach, because there's no way that you would have been able to do this with complete correctness. But if you gave good debug output and you gave people the right tools to solve dependency problems when they cropped up, right, I think that this would have been a very viable solution, right? Let's say that like you have a dependency that needs new functionality and you're an old. If we gave you a tool that said, here's the exact thing that you need to upgrade to use this new dependency, not you got to go use this entirely new module, right? And upgrade every single call thing and take the whole thing. No, just this little thing. If you change this little thing, everything's going to work out for you, right? You lower the burden for people having to adopt new things by a huge amount. And you actually have an ecosystem that at least isn't founded in a lie, isn't founded in a fantasy, right? Because that's what we're all doing right now, right? We use dependency management tools and dependency management systems that are founded in a fantasy that does not exist in our reality. And like the industry needs that kick. It needs something or somebody to do this. And I think Go was, and actually still is, positioned to do this. And I think what we all have to decide is like, do we want to invest in that? And I think that I fundamentally believe that we should invest in that. I think we should build new dependency infrastructure for Go that does this sort of thing. It might not get adopted a lot, but just putting that out into the world, I think would help give us that diversity that we need to kind of break away from the stuck place that we have been for a good while now.
Yeah, I mean, like I'm looking at what one of my colleagues did at Oxide to support versioning in the API. And they had to write a lot of like machinery around Rust to just make sure that we can have versioned types, right? So that way, if you called the API at version 1 and really the API is deployed at version 3, it would do all the translations of the types and the schemas to like make sure that API response went, to and from. But like why can't the language provide more support for these things? Why is it why is the entire onus on the user? Like why can an application only have one version or something, right? Why can a function only have one version? Like we can do different things here, and the languages can. We have all of this programming data now of how we're using programming languages and modern problems. Programming languages can start to like include some of this more to help us with these things, rather than saying like, oh, you know, we've given you the building blocks, go build things. It's like, well, no, you know more than just the building blocks. So like, why don't you actually do my foundation for me? Like, you know what I mean? Why don't you actually do this part for me? And then we can go from there. And there's more to be done. It just feels like if you're going to take the effort to build a new programming language or to modify an existing one, at least have a goal that's not just like, oh, we're slightly different. You know what I mean? Like be radically different. Go for it. Go be like, hey, listen, this approach now is going to solve this versioning problem that we have because we're tired of this being a problem, and we're going to just try to solve for it at a lower level than you're used to. Let's go. Let's try it. And instead of doing that, we're all just creating another toy language and saying, yeah, use us, please. We're faster. we're 2 milliseconds faster. Yay. Like, come on. You know what I mean? Let's solve a real problem again.
Yeah. And I think it's we all have to realize that like just because we've messed things up in the past doesn't mean we can't fix them now.
Right.
Like, doesn't mean we can't, you know, have a resurgence, have a comeback. Everybody loves a comeback story. So it definitely feels like something that we should all do. And I think like I feel like with SemVer, we're all running up against a wall constantly and like thinking that eventually we're going to solve the issue. And I think that this, you know, relates really well to a topic that I want to bring up because it's not a tech specific thing. It's a world specific thing. And that is the electrification of vehicles, right? I think everybody knows it.
This is the problem, I think. I think this is the sum of what that sort of Bell Labs, MIT, NJMA sort of thinking is like the NJ sort of thinking is more holistic in nature across domains, right? It sees a broad set of things and solves for it in that holistic way, right? And the sort of MIT way of thinking is very deep, correct thinking about a single domain, not always crossing into different domains and seeing how it affects one another. You know what I mean? So it's like, yeah, sure, you built the perfect car or shoe or phone, or it doesn't even really matter. Pick anything. You pick the perfect, you've designed and built the perfect thing that nobody can use because you didn't consider the audience, you didn't consider how to produce it, you didn't consider any of that stuff. You just focus solely on this perfect vacuum world and you solve for that. And congratulations. It is you've made something very technically beautiful and whatever, and you probably learned things along the way that will help other things, but you didn't solve the problem at hand. And in the New Jersey way of thinking is like, actually, let's solve the problem at hand here and not go crazy. And then eventually when things shift, we'll figure it out again. And like both, again, I want to reiterate here, even though I have my New Jersey bias, obviously, because this is where I am, both are not totally correct and not totally incorrect. There's a time and a place for each thinking. And you can see the positive effects and negative effects of each approach depending on the lens you're looking through. Like we discussed rocketry before, right? Like that MIT approach is very, very nice there because you do want to make sure everything's perfectly correct because your domain is very narrow. You know, it's rocketry. You don't care about sort of how, launching a rocket in Florida affects those over in Alaska. Like you just don't care about that because that's like out of your purview, basically. Obviously it can, right? Rockets can go anywhere. But that's just the thing. You focus deep on a problem, you solve for it. And the New Jersey way of thinking is like, hey, actually, these electric cars that we have everywhere, first of all, we rely on our gas tax. Who's going to pay the gas tax? How are we going to make our roads better? Oh, they're heavier. They're killing our roads at a faster rate. And they're not paying gas tax for it. What's going on here? And you have to solve for that. And yeah, I wish I would see the industry do more of this holistic thinking.
I think a way of framing this as well is like it's like the monolith versus microservices approach, or an even better one, it's like the closed versus open ecosystem approach, right? Like I think those are kind of like equivalent with the respective ways, where it's like if you think about monoliths or really like the Apple ecosystem, right? It's like you're in or you're out, right? You gotta like, here's all the stuff. Here's if you're in the Apple ecosystem, everything works together beautifully. It's all like everything syncs together. It's great. It's wonderful. It's nice. But if you have one thing that doesn't fit with that, the whole thing, it's like, okay, well, this is not nearly.
It collapses.
Yeah. It's not nearly as nice of an experience because it's a close thing, and that's very much like the MIT approach of like, hey, like we're gonna create this perfect world for you, but you have to follow all the constraints because we have this thing of correctness and you have to be in it. And that's, in contrast to like the kind of more open ecosystems, right? It's like iMessage versus RCS, where it's like, okay, yeah, iMessage is nice, but it only works if you have iPhones and, Macs. Whereas if you use RCS, that works for like everybody and it's this open thing. And it's not as, it's not as feature rich as iMessage is. So it's not as correct or perfect, but it allows you to do so much more because it's the open way of doing things. It's more focused on just trying to make it good and trying to make RCS good instead of trying to be part of a larger ecosystem that can do things.
Right.
So I think like those are also other ways of looking at this dichotomy where it's like, yeah, is one better than the other? Like, I don't think so. And even the guy that wrote the worse is better essay wrote another one arguing from the MIT perspective is good. And then he said like, I don't know which is better. I can't really tell you which one is better. I think that's the important point is like whichever one you use, you have to really sit down and be pragmatic about it and say, has this solved the problem or will this solve the problem? And if one of the two methods of doing it doesn't solve the problem, then you should probably use the other one or a different ideology that will solve the problem.
Yeah, I agree. I think that's a good place to call it then.
Yeah, I think so. Yeah, on to break first. So, viewer/listener, that was a pretty interesting conversation. As per usual, it went in a different direction than I think Matt and I thought it would when we sat down and planned this, but it was a fun conversation regardless. What do you think, though? How did you think? What were you feeling as we were saying what we were saying? Let us know in the comments, in social media, in Changelog, Zulip, or on Gopher Slack. This episode of Fall Through was hosted by Chris Brando with co-host Matthew Sanabria. Fall Through is produced by Chris Brando and Angelica Hill, and our beats are by Breakmaster SemVer. Sometimes I can do intros, and sometimes I cannot.
I don't know why I'm waving my arms, but I'm angry or happy or something.
Yay.
Yay.
Being a weirdie.